Subset takeaway. If you're one of the people that I think are watching this, hello. It's good that you're watching this and learning. If you're a member of the general public who stumbled upon this video with the magic of the YouTube algorithm, I just want to say, well, first of all, hello to you too. I won't deprive you of that. But second of all, I'm just going to circle this one here and say, well, circle and draws a rectangle thing. Yeah, you want to trust me for maths? Anyway, I just want to say I'm not a math person. I could be wrong. That's a disclaimer. I'm not a teacher. I'm not anything like that. And I'm not even sure I have this concept correct. So keep that in mind while you watch it. Don't take everything as gospel. Do your own research, but there will be a link in the description to a thing that I show here. You'll see that later. So, subset takeaway. Subset takeaway is a two-player game involving a fixed finite set of E. Players take turns choosing non-empty sets of E with the conditions that a player may not choose the whole set of E, nor any set containing a set that was named earlier. We'll go over the rules in a bit more detail shortly. The first player who is unable to move loses the game. For instance, if E equals the set of 1 and 2, then the only legal moves are 1 and 2. Each is a good reply to the other, and the second player always wins. Show that if the cardinality of E is equal to 3 or 4, the second player can also always win. In other words, he has a winning strategy, or, she might have a winning strategy too. But anyway, for this challenge, I recommend you to try. Okay, I don't need to read that bit. So, let's go over the rules of subset subtraction. Wish it was called subset subtraction. It's a bit more catchy than takeaway. But anyway, so we can't choose the entire set of E. So fairly self-explanatory in the world of discrete maths. Basically, if your set of E contains 1, 2, and 3, player 1 can't choose the set of 1, 2, or 3. They have to choose a subset of E that is not the entire set of E, and I should write this down too. They also can't choose an empty set. There you go. So it's actually 4 rules. So basically, your set that you can choose as a player can't be an empty set or the entire set of E, but it can be any other subset. Number 2, crack the highlighter out. So we've covered that rule. We've basically covered that rule. Number 2, we can't choose any superset of a previously chosen set. Initially when I read this, I thought it was subset. I think it's superset because if you notice here, it says you may not choose and then blah, blah, blah. You may not choose any set containing a set that was named earlier. So it makes it sound like you can't choose a set that has something that was already chosen. So if we look over here, just as a reminder, we've kind of got a little superset graph. So B is a superset of A. So if player 1 picks A, picks whatever's in the set of A as their thing, then player 2 can't pick whatever's in the set of B because B contains the set of A. Fair enough. And the last rule with a question mark, because I'm like that, subsets are okay. Doesn't say they're not okay. The rules are a little confusing on this slide, I feel, but that's life. So hopefully they are okay. Otherwise, I'm wrong. So as indicated in this example here, so we've basically got E with the set of 1 and 2 taken care of, but let's first have a look at, let's not move the picture. That's probably the right spot, hopefully. Yeah, alright. So, if only there was some sort of original source that we could look at. Perhaps this one. Oh, there you go. And here it is. So, the first bit of this is just explaining the game. So, basically, everything up until, yeah, so that, don't like that. So that can go. So I'll get our highlighter again. The first interesting case is when A is equal to 1, 2, and 3. I probably didn't make it clear. I just crossed that out because it's basically reiterating what is up here. Cool. In response to any first move, the second player, any first move in reference to this set here. In response to any first move, the second player may choose the complementary set. This produces a position equivalent to the starting position, where A is the set of 1 and 2. So, if I can quickly draw that up here. So, E equals the set of 1, 2, 3. Boo! And then, let's say player 1, which will represent with that, picks 1. Then P2 can pick, if player 2 can always win, not will always win, but can. So we're only demonstrating that it's possible. Player 2, if they want to win, will pick 2 and 3 as their set. So now we can't include anything with 1 because 1's out because it got picked, and anything with 1 is now going to be a superset of 1. So guess what? That's gone. Now E is kind of left with 2 and 3. And would you look at that? That's a situation that's quite familiar because I've got the eraser on, because okay, I'm not going to draw an arrow all the way up there, because this E has 2 elements in it. Oh, that's pretty cool. So at that point, you've got E with 2 elements, and more importantly, straight after you have E with 2 elements in it, player 1 can go again, since an even number of turns has taken place. So there's turn 1, there's turn 2, now we're up to turn 3. So as long as you end up with this 2, with a set of 2, and it's player 1's turn right after that happens, then player 2 will win. Fantastic. But and I'll demonstrate the second case very quickly. So let's say, so of course we had player 1 pick a set containing, wait, okay, yeah, player 1 had a set of 1, a set with a cardinality of 1 with the number 1 in it, I should say. So what happens if they do 1 and 2? That's different. Well, player 2 can just pick 3. Now we can't use the number 3 at all, because anything with the number 3 will be a superset of number 3. So guess what? 3 is gone, 3 is gone, and then we go 1 and 2, which is exactly the same as what's up here, and it's player 1's turn. Player 2 will win. Fantastic. So we've taken care of every single case here. So bye-bye with that. And I should mention here, the document here just the eraser. Oh, well, I'm not going to rub that out again. The document here has A as the set that's in the game. Up here it's E. I'm going to use E here. Just know that when it says A here, just think of E. So that shouldn't be too hard. So how we prove that is basically by saying I can zoom in further, that's cool. So we took this set that's here and kind of turned it into this set here. And since we already proved that this set here is possible in terms of a, what's it called, player 2 winning, then we can also like conclude that it is possible for player 2 to win with a set of 3. But what about, well, we've concluded that player 2 can always win, I should say. I should be very clear with my words there. We're basically trying to talk about the fact that player 2 can always win with 2 sets with the cardinality of 3 and 4. So yeah, we've proved 3, or rather, they proved 3. But we got to prove 4 now, don't we? So what do? Well, oh, that's handy. I forgot I did that. Here's E with a set of with a cardinality of 4, with the numbers 1, 2, 3, and 4. So there are going to be 3 cases that can take place here. Case 1, P1 picks 3 elements, so we'll just say they're 1, 2, and 3. Then what can happen is player 2, being the smart people that they are, will pick 4. And since 4, or anything with 4 now, will be a superset of 4, I should say. And we also can't repeat a previous set. Then, you wouldn't believe it, but we're now left with a set of E that equals 1, 2, and 3, which, wow, that might be one of the worst curly brackets I've done. There we go. Which looks awfully familiar because it looks like this one. And since we've established that this one here can become this one, and that this one here guarantees a victory for player 2, then we've basically taken care of case 1. I mean, we'll go through the rest just so you guys can visualize it. So, you know, P1 will pick whatever. I mean, we've kind of, I've rubbed it out, but there were 2 different cases where player 1 could pick 2 elements or 1 element. Let's just say they pick 2 elements, and then player 2 picks, what's the one left? 3. There we go. And then player 1, it's the same thing. So E equals 1 and 2, and then player 1 picks 1, player 2 kind of goes, ha sucker, I can pick 2, player 1 can't do anything, loses. So that's pretty cool. But what if player 1 picks 1 number instead? And you'll see why we're going from 3 to 1 here. So we'll go case 2. Will that turn into... That's good enough. Case 2. P1. Try that again. P1 equals 1. So they just pick the number 1. Then what P2 does is they can just pick 2, 3, 4. I won't draw this one out completely, but since player 1 picked 1, and only 1, that means anything with the number 1 cannot be included anymore, and we can only pick subsets of 2, 3, and 4 now. So E is now a thing with 3 elements, 3, 2, and 4. I did that wrong. Just pretend, no, I can't deal with that. 2, 3, 4. And then it continues the same way as it does here. But case 3. What happens if, so player 1 can pick 2 numbers. So let's say, it's making it hard. Let's just pick 1 and 2. Player 2 can then pick 3 and 4. So now E is kind of 2 sets of, this is the weird one to explain, but basically it's a set with 2 sets in it now, but how do I draw this? 3, 4, hope you guys can read the curly brackets. So basically we can't pick a superset that includes 1 and 2 and 3 and 4. So what we have to do now, basically what we've got are 2 sets of 2, and now we're basically playing the same thing as what's depicted here, but we're doing it twice, but in the same game. So player 1 can do anything at this point, so they can't pick 1 and 2 and they can't pick 3 and 4. Actually, there's 2 cases here too, but alright, you know what? We're doing something on the fly. Alright. Case 1A, I guess. So P1 might pick 1, and then, and then P2, should be doing equal signs. P2 can pick 2 at that point, and then all E has left is 3 and 4. So now it's just the same game as demonstrated in the slide. I'm not going to go there again, with the 2 things. Very good. Now, what if, and we can also figure out that if player 1 just picks 3, then that's cool too. But hopefully this is good. Case. Alright, you know what? I'll just mention that it's an unknown. So basically, I don't know if player 1 can pick a set of 2 and 3. So basically, I don't know if they can grab this number and then go like that. And like, it's a bit confusing. So yeah, I don't know. That can be what one of you guys might say. You might have a correction. Anyway, I think that's it. Goodbye.